Hello, my dear friends. How are you? Hope you're fine. Study well. Whatever the studies. Okay, study well. Today we are starting a new chapter, the fifth chapter, that is surface chemistry. Okay, surface chemistry. From the name itself, you may identified what are what are the things that we are going to study. Yes, that is the relation, the reaction that take place in the surface. Without wasting time, we are directly going to the chapter. Okay, what is surface chemistry? Surface chemistry deals with the phenomena that occurs at the surface. Surface chemistry deals with the phenomena that occurs at the surface. Okay, what is the aim? What are the things that we are going to study in this chapter? Okay, let's discuss one by one. In this chapter, we will describe the surface phenomena and its significance. In this chapter, we will describe what are some surface phenomenon and its significance. And then we will study about adsorption and what is adsorption and its mechanism, and we will explain the fact is controlling adsorption. Okay, we will explain the fact is controlling adsorption. Okay, and we will classify the emulsion and we will study the properties of emulsion and some more topics, etc. We will study in this chapter. Okay, we can directly go to the chapter. What is adsorption? What is adsorption? Adsorption is the accumulation of molecular species at the surface rather than in the bulk of a solid or liquid is termed as adsorption. That is, the reaction is fully focused. The accumulation of molecular species occurs at the surface. No involvement of in the bulk is occurring here. That is, no involvement of bulk is here. Only the surface. The reaction is between the surface. But the point, it is adsorption. What is adsorbate? The molecular species which concentrate at the surface. That is, what is reacting with the surface is adsorbate. But the point, it is adsorbate. What is adsorbent? That is itself the surface. The material on the surface of which adsorption takes place is called adsorbent. Okay, we already said that adsorption is a surface phenomenon. We already said that adsorption is a surface phenomenon. Okay, we will take some examples of adsorbent: charcoal, silica gel, alumina gel, clay, colloids, metal in finely divided sets. These are examples of good adsorbents. Okay, this is a very simple topic. No need of much discussion. Okay, we can go to next point: adsorption in action. How the adsorption work? Okay, if we take gases like oxygen, hydrogen, carbon monoxide, chlorine, or etc., is taken in a closed vessel. If some gas is taken in a closed vessel containing powdered charcoal, then what will happen? It is observed that the pressure of the gas in the enclosed vessel decreases. Okay, that is the pressure the pressure is firstly we are calculated, and after the vessel is closed, then the pressure is again calculated. It is observed that the pressure of the gas in the vessel is decreased. What happened at that? Yes, the gas molecules are what happened at? Yes, that is adsorbed at the surface of charcoal. Okay, the gas molecules are adsorbed at the surface. Okay, we'll take an example of adsorption. When methyl blue dye, that is dye, is colored methyl blue, dye is taken in an animal charcoal. Is methyl blue dye is added to an animal charcoal. Okay, what will happen? And shaken well. What will happen? Yes, then the color become changed to white or colorless. The color of the dye is become colorless. Okay, what will happen? The molecules of the dye are what happened? Adsorbed at the charcoal surface. Okay, the molecular dye are adsorbed on the charcoal surface. Okay, we know how the sugar become colorless. Yes, the color of roast sugar become colorless by passing over beds of animal charcoal. Okay, we already said in our previous classes. Okay, the air become dry in the presence of silica gel. The air become dry in the presence of silica gel because water in the water molecule get absorbed on the surface of the gel. Okay, so if you're using a silica gel, the surrounding air become dry because the water molecules present around the silica gel become absorbed on the surface of silica gel. Got the point? Okay. What is desorption? Yes, desorption is a reverse. That is the process of removing the adsorbed substance from a surface in which is adsorbed is called desorption. The process of removing adsorbed substance from the surface is called desorption. Okay. We can classify or we can check what are the differences between adsorption and absorption. Difference between adsorption and absorption. Okay. First one. Adsorption is concentrated only at the surface. Adsorption is concentrated only at the surface. In absorption, the substance is uniformly distributed throughout the bulk of the solid. That is the main difference, first difference. Okay, surface phenomena, bulk phenomena. Okay, example, water vapor are absorbed by an anhydrous calcium chloride. Water vapor absorbed by anhydrous calcium chloride but adsorbed by silica gel. That is the difference. Adsorption, absorption. Okay. In adsorption, the concentration of adsorbate increases only at the surface of adsorbent. In adsorption, the concentration of what the adsorbate increases only at the surface of adsorbent. While in absorption, the concentration is uniformly throughout the bulk increase. Okay. Concentration of adsorbate is constantly uniformly increases in the bulk. That is the difference between adsorption and absorption. Mechanism of adsorption. What is the mechanism of adsorption? Okay. Adsorption arises due to the fact that the surface particles of the adsorbent are not in the same environment. Adsorption arises due to the fact that the surface particles of the adsorbent are not in the same environment as the particles inside the bulk. That is, the particle inside the bulk and the particle in the surface are in two environment. Okay, this is the main reason. In the bulk, the particle is surrounded by surrounding atoms, and in bulk, it is an unbalanced force is existing. Okay, that is inside the adsorbent, all the forces acting between the particles are mutually balanced. But on the surface, the particles possess an unbalanced attractive force. On the surface, the particle possesses an unbalanced attractive force. Got the point? Okay. And these forces of adsorbent, these forces of the surface are responsible for attracting the adsorbate particle on the surface. And the surface particles have an unbalanced force, and this unbalanced force attract the adsorbate to its surface, and which leads to the formation of adsorption. Okay. The extent of adsorption increases with the increase of surface area. Yes, as the surface area increases, the extent of adsorption increases. Okay, that is surface area of adsorbent. Next, during adsorption, there is a decrease in surface energy which appears as heat. That is, adsorption is an exothermic process. Delta H of adsorption is negative. During adsorption, what happens? Yes, there is a decrease in surface energy. There is a decrease in surface energy. Delta H of adsorption is negative. During adsorption, there is a decrease in surface energy. Okay. When a gas is adsorbed, what will happen? The freedom of movement of its molecules become restricted. freedom of movement of molecules become restricted. That is, the entropy decreases. Delta S is negative. That is for absorption. Adsorption delta H and delta S are negative. Got the point? That is, adsorption is thus accompanied by a decrease in enthalpy as well as decrease in entropy of the system. Adsorption is thus accompanied by a decrease in enthalpy as well as a decrease in entropy of the system. Okay, by thermodynamic concept we have for a process to be spontaneous. What is the condition? Yes, delta H must be negative. Okay, delta H, not delta G must be negative. For a process to be spontaneous, it is required that delta G must be negative. In the case of adsorption, delta G is negative, so yes, adsorption is a spontaneous process. Adsorption is a spontaneous process. Okay, let we can move to the next point, that is types of adsorption. Types of adsorption. There are mainly two types of adsorption: physical adsorption or physisorption and chemical adsorption. Physical adsorption and chemical adsorption. We can study what is physical adsorption. Okay, if the accumulation of gas on the surface of a solid occurs on account of a weak van der Waals force, the adsorption is what? Yes, adsorption is physical adsorption or physisorption. That is, the force between surface and the adsorbate is only a small van der Waals force. Then what will happen? Yes, the accumulation, the adsorption is called physical adsorption. Okay, then what will be the chemical adsorption? Yes, when the gas molecules or the atoms are held to the solid surface by chemical bond. When the gas molecules or atoms are held to the solid surface by chemical bond, the adsorption is called chemisorption or chemical adsorption. That is the difference in the bond between the adsorbent and adsorbate. It is two categories of adsorption: chemisorption and physical adsorption. If van der Waals force, it is physical adsorption, and if chemical bond formation, covalent ionic bond is formation, leads to the formation of chemical adsorption. The chemical bond may be covalent or ionic in chemisorption. Chemical adsorption involves a high energy of activation and is referred to as activated adsorption. Chemisorption involves a high energy of activation and is referred to as activated adsorption. Okay, but in the case of physical adsorption, there is activation? No. A physical adsorption at a low temperature may become chemisorption at a high temperature. A physical adsorption at a low temperature can be converted into chemical absorption at when the temperature increases. That is change. Okay. Physical adsorption may change it to chemical adsorption by increasing the temperature. Okay. That we can study the characteristics of physical adsorption or physisorption. We can study the characteristics of physical adsorption or physisorption. Okay. First point, lack of specificity. That is, physisorption lacks of specificity. What is that? Yes, a given surface of an adsorbent does not show any preference for a particular gas. That is, a surface does not show any preference for a particular gas in physisorption. That is lack of specificity. Okay. Next, second point, the amount of gas adsorbed depends on the nature of gas. That is, nature of adsorbate. Okay, what is the nature of gas? What is the nature of adsorbate? Yes, in the case of gas, easily liquefiable gases are readily adsorbed. In the case of gases, easily liquefiable gases are readily adsorbed. Okay,